introduce you. Olowode is right.
Olowode.
Perfect. Olowode is right.
Yes.
A big applause to her.
Thank you. Thank you so much. So thank you, everyone, for coming to my talk. As he said, my name is Abiodun Olowode, but AB for short. I'm currently an engineering manager at Clio, a company in the UK which is trying to change the world's relationship with money. Before then, I worked at Factorial, also as an EM, but before that, as a software developer on multiple core teams, product teams, and a developer experience team. Today, I'm going to talk to you about something I'm quite passionate about, and I hope that after this talk, you become passionate about it too. So today, we're going to be talking about code craftsmanship, treating software development as an art form. It's easy to think of software development as a science because, after all, we have to know some things about CS. But today, I'm going to be trying to steer us towards seeing it as an art form. Haven't heard the title. I know it's kind of long. Some of us will be like, I'm not an artist. I'm a developer. Why would you compare me to an artist? I don't paint. I code, right? Nevertheless, that's a fair point, but as I said earlier, I hope that after this talk, we begin to see software development as an art form, and as a result, hone our craftsmanship. So let's start with the basics. What is craftsmanship? Craftsmanship can be said to be the skill at making things, or the skill with which something was made or done. So the skill that went into making something, or the skill that went into building something can be said to be what? Craftsmanship. I hope everybody can see, even though you're behind. Can you say yes if you can see? Thank you. I know that we rate the talk, but I don't know if you know that I'm also going to rate you as an audience after. So if you want me to give you 5 stars, be very responsive. Also, we can define craftsmanship as what skilled artists and builders demonstrate when they create something. So the skill that you show when you create something or you build something can also be said to be craftsmanship. Take a look at this. What do you think it is? This is a wood carving, and we can see here that it's trying to portray something to us. If the elephant looked like a goat with a horn, or the trees looked like human fingers, this would be a disaster. But I'm sure everybody here can identify what the carver is trying to portray, even though they are not here to say exactly what. Yes? Can everybody see what? Okay, so this is an example of craftsmanship. Craftsmanship can also be said to be the quality that something has when it is beautiful and has been very carefully made. As developers, we understand that logic operators are very important, right? So the one here too is very important, and I'll tell you why. I'll read this again. The quality that something has when it is beautiful and has been very carefully made. I'll show you why this is extremely important. Take a look at this. In one word, I want you to shoot me with words that come to your mind to describe this. Let's go.
Rich.
Oh, wow. Nice. What? Boring. Boring. I need to question your taste. Like, you need to see me after this talk so we can discuss that. Any other words? Clean. Whoa, wow. Modern. Nice. Now, hold that thought. Just hold it. Would you still think the same if, when you try to go into the building, the door handle falls off? You try to turn on the tap, and the tap handle falls off. Or you try to turn on the light, and the bulbs don't work. Or you try to go into the bathroom, and the tiles are broken. Turn on the heater, and the heater doesn't work. And if you live in the UK like me, where it's always raining, it starts to rain, and then water gets into the building. Now, would you still describe that building with the same words? I'm not Italian. What does that mean? Oh, scam. Thank you, thank you, thank you, thank you. So, this is to say that craftsmanship isn't just about getting the job done. It's about doing it so well that your work stands the test of time. Before it begins to look as if this is a class for plumbing, carpentry, woodwork, let me remind us of what we're speaking about. The topic is code craftsmanship, treating software development as an art form. So, what is code craftsmanship? Extrapolating what we know now about craftsmanship, what can we define this as? We can say it is what skilled developers demonstrate when they create software that is efficient and maintainable. We can also say that it has to do with the care with which the code was written or structured. Are all the classes related to different behaviors all lumped into one class? Have you ever wondered why can't code always be this good? Have you read code that gave you goosebumps? Code that made you feel ecstatic? Have you ever seen such code? I read something on LinkedIn a few days back, and I didn't agree. It was a post that said, developers always hate code that isn't written by them. That's not true, is it? Is it? Oh, wow, okay. I have seen code, and then I was like, oh my God, who wrote this? I need to give them a hug. Like, it was amazing because it was clear, it was understandable, it had a decipherable flow, and I was like, this is amazing. When we ask developers, why can't code always be good? Someone posted this on Reddit about how overwhelmed he is at his newfound job. And the person who took this screenshot from there made a LinkedIn post and said this: when the success of a company depends on having to move fast, grow fast, and change fast, you 100% end up with legacy code, dead code, tech debt, and bad practices. Even more so when new teams are added frequently or new members join your team. I read this and I felt good and bad at the same time. I felt bad because what kind of new members are joining a team that 100% assures us that we're going to have bad practices? Like, really? But I felt good because I was going to give this talk. And I was like, this is exactly what I hope to address with my talk. When you ask developers, why isn't code good? They say, you know, we have to move fast, we're under deadlines and all of that, so that's why. As long as it works, it's fine. Well, I beg to disagree. And that's why we're talking about code craftsmanship. There's a paradox I find that happens to stand in the way of code craftsmanship, and I've called it the business quality paradox. There seems to always be tension between two forces, the need for speed and the demand for quality. On the business side, we've got deadlines, market pressures, customer demands, and the business wants this shipped when? Yesterday. On the side of the devs, we understand that we do not only need to create software that is functional, but also reliable, scalable, and maintainable. I call this a paradox because these two forces always seem to be at odds, thereby putting us in very difficult situations. Quick fixes become bad habits, and before you know it, we're left with a mounting pile of tech debt. We can be able to say, yay, we shipped on time because we were fast, but before you know it, ta-da! That's what we see. And then that's when your PM begins to ask you stuff like, why is it taking so long to ship this little feature? Take a look behind, that's why. That's exactly why. Now, we're not so fast anymore, eh? We were moving fast before, but we're not so fast. We're at that point where we're beginning to experience the consequences of sacrificing quality for speed. Aside the fact that now we have an accumulation of tech debt, we then have increased maintenance costs. Developers spend more time trying to understand how a system works before they can extend it, create new features, or fix bugs. You know, the worst part, maybe not the worst, the worst, because I'll still go to the worst. The worst part is changing code in one part of the system inadvertently breaks another. Have you ever experienced that? You ship something and you're like, and then you hear, prod is broken. And you're like, yeah, it has nothing to do with what I shipped. Those two parts are totally unrelated. And then there's a little digging, and it's you. And you're like, how? Those two parts are not supposed to be related in any way. We're at that point where we're bearing increased maintenance costs. Now, the worst part, I said worst and worst. The worst part is onboarding new developers. They don't only have to find out how the system works, they also have to familiarize themselves with our tech debt. So it's like, yeah, this is how this place works, but now I have to explain to you how this or that part works because blah, blah, blah. And then that leads us to developer frustration. How many of you have ever been frustrated? Oh, we're all in the same Facebook group. And inadvertently, that leads to customer dissatisfaction. Before it begins to look like I'm a prophet of doom and gloom, and all I'm saying is bad news, I'm happy to say that I have some good news. And the good news is quality and speed are not mutually exclusive. Should I say that again? Quality and speed are not mutually exclusive. Fast doesn't always have to equal shitty. Tell your neighbor, fast doesn't have to equal shitty. Fast doesn't have to equal shitty. Yes, that's what I'm trying to say. That. Exactly that. I'm trying to tell you that you can ship fast, but still to a high quality. There is a way that we can balance the paradox of speed and quality. I've put together a few principles, but if we are ready to dig into how we can balance this paradox, I'll tell us one thing first, and that's something that skilled developers understand, which is tech debt should be a business decision. I'm not saying tech debt is always a business decision. I'm saying it should be a business decision. So, well, if wishes were horses, beggars would ride. There are two kinds of tech debt: intentional tech debt and unintentional tech debt. Intentional tech debt has to do with making a conscious decision to adopt a design strategy that isn't sustainable in the longer term, but yields short-term benefits. So it's like we have strategy A and B. And in order to get into the market early and boost our funds, we need to release this in 2 weeks. If we take strategy A, we'll be able to go out in 2 weeks. But if we take strategy B, which is the better option, we'd need to have some building blocks in place in order to ship with strategy B. So conversations happen, and we wait and say, are the gains more than the interest? Sometimes we don't eventually go with strategy A because the gains are not up to the interest, and it will be a bad debt. But intentional tech debt is about weighing the gains and the interest and saying, okay, we know that this is not sustainable in the longer term, but we're going to ship this first. That's intentional tech debt. Unintentional tech debt is adopting poor coding practices that result in code that's difficult to scale or maintain, sometimes due to a lack of expertise. Now, this is the kind of tech debt you want to avoid. It is not a business decision, and it's just going to land you into deeper messes. Are we ready to see how? Remember, I'm rating you. Okay, I've put together a few principles to help guide us in the right direction. It's not an exhaustive list, but it's a start to help us see how we can avoid unintentional tech debt. Remember, we're on a journey to balancing the paradox of speed and quality. First one, clarity over cleverness. Martin Fowler said, any fool, I didn't say it, Martin Fowler did. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. Do you need some time? So, I think that a lot of developers see code only as a way to create software. Why do we write code? I'm trying to create software. But I want us to have a mindset shift today. With code craftsmanship, we see code as a way to communicate with our team. So code isn't just creating something. It should tell a story about what it is doing and why it is doing it. Except you run a one-man business and you know that you're going to be the only dev there forever and ever and ever, and you have a photographic brain that remembers everything. You should see code as a way to communicate with your team. How many of us here do Ruby as a programming language? Nobody. Oh my God. Anyways, I have some examples in Ruby because it reads like English, so I'm sure we can all follow. Let's take an example. Yes, pretty clear. Everybody can see, yeah? Thank you so much. 4-star now. That was a very good response. So we're going to go through this piece of code, and let's see what happens. First line, MRS equals ir.check message. I used MRS because I've come into contact with MRS in code before. I read it as Mrs., and I'm like, who got married? No, this is code. Nobody did. And then I found out it meant message representation. Please don't do this. So MRS is ir.check message. Now, if MRS.include payment, return billing. If it includes shipping, return logistics, else return support. And that equals to what? Why are you scared? Don't worry. There's no wrong answer. That is equal to T. What does T mean? Do you know? No idea. Now, P equals message that include urgent, high, else low. Now you can say, okay, P. If the message includes urgent, we return high, else it's low. So P might mean maybe position. Well, because you saw it below. Well, and then we go to conversation.create message team, priority. And you're like, team, T. Oh, so what T meant was team. And then you go, oh, priorities, P. Yeah, it's a no-brainer. But this is a very simple example. But the deal here is, how many times as devs do we have to read an entire code or go through 5 different classes to understand what a piece of code is trying to achieve? Imagine the time that we're wasting because someone tried to go fast by writing shitty code. So are we really going fast? Maybe not, maybe yes, we'll see. I updated the code. So now, intent equals intent recognizer dot recognize message. So we want to know the intent of the message. In case you've forgotten, that's what IR means at the top, intent recognizer. Yes. MRS, message representation. Or Mrs.
Are you sure it's Ruby? It looks like Go.
Okay, so the first line, intent equals intent recognizer dot recognize message. So now you know that we're trying to recognize what the intent of the message is. I don't even need to explain that to you. The next line says team priority. We get that from intent mapper.map team and priority to the intent. We don't know what's going on in that class, but we do not know that there's a certain class where we send an intent, and it maps that intent to team and priority and sends that back to us. And then conversation.create message team priority. Does that read clearer? Yeah. Do you understand the story? You do. So can you imagine how much faster you would go if you just read this, you're like, cool, I get what they're trying to say. And you move on. Now we are moving fast because we valued clarity over cleverness. So this is the code. Reads easy, reads cool, and we're moving fast. Second thing, leave the code better than you found it. Refactoring should be a regular part of your workflow. Improving code should be just how you work. This is just how I do things as a developer. You remember this shitty code? Imagine that we had a new team. Remember that T means team. And you ask a developer, you give them a task, and you say, can you include a new team here, because now we have accounts. I hope nobody here, I'm going to say some people, but I'm sure nobody here will do that, will come here and just add another else if. Else if MRS does include account, return, account, and we're done, right? And one thing you should know is this code would always work. This code would always work. It is very functional, and it does what it should do. But it's costing us time, even though it does work. Don't be that developer. If you see this, change it to this. So the next time someone has to add a new team, they don't need to read the entire function to understand what's happening. They come here and they're like, oh, team, priority, intent mapper, and they go into that class and they do what needs to be done. Testing vigorously. Interesting. Do you remember when I asked if any of us have ever been in situations where you ship code and you're like, I didn't break anything, when you hear something is broken, and then you finally realize it was you? If we had tests, then maybe they would catch it before you break production. But the funny thing I find about devs, I still code actively, even though I'm an EM. So let me not say one thing I find about devs, about us, is that we get upset when there's no test for something that we are about to change. But then we have reasons why we can ship code without tests. We have reasons, we have legitimate reasons. You know, this happened, that class is so complex, I can't do this right now, we need to move fast. But then when you want to change something, and then you're like, where's the test? How do I know I'm not changing something? You're like, who wrote this? Why is there no test? But you ship code without tests. So the next time you attempt to ship code without tests, remember, all of the parts of code you cannot improve on the go because they have no tests. Use design patterns. Design patterns offer proven solutions to common software problems. Design patterns are kind of very important, and sometimes we feel like they are a bother because I could do this in a very easy way and just keep extending stuff. Let me give you an instance. Do you remember this class? Intent mapper. Imagine the class looked like this. So this is what the intent mapper does. If the intent is sales, we map it to a team sales and then priority high. If the intent is help, then we map that to team support, priority medium, and so on and so forth. Now imagine that in our company that we all are stakeholders in, this company grows so well, and now we have 100 teams. We have 2,000 developers, and we have data scientists. Where I work, we have machine learning engineers, data scientists, product designers, content designers, like a whole lot of people. And now, we have situations where intents can map to the same team. As opposed to before where there's one intent, but now we have so many users and data scientists have told us of like 6,000 intents. Do you know it's possible for this object to just keep growing? Have you never seen that before? Why are you acting so innocent? And then everyone just comes and adds something here. We just add it and we're done. And before you know it, there's this file with 1,500 lines. And you just keep scrolling and it's just this hash with many keys and values. That's why we have design patterns. Imagine that we changed it to this. So now we have one intent mapper interface, and then we have several individual intent mappers that map team and priority based on their domain. So we have one for finance, we have one for accounts, we have one for shipping, and this becomes more modular and we can test it more easily. Yes? Yes, I needed to add this part because it's like, AB said we should use design patterns, now let's go. Calm down. Avoid over-patterning. Not every problem requires a design pattern. A simple solution is always best. Let's try to adopt design patterns only when they fit in naturally. So do not overcomplicate stuff because you want to use a design pattern. Now, the last on my list of principles, but not the least, the one I consider maybe the most important is this. Do you need some time? I want us now to be very sincere. Remember that I would rate you, yeah? If you are the looks good to me person, raise your hand. Most of us are. Like, we're moving fast, so we don't even type looks good to me. It's like LGTM, approve, good, and we all go. Don't be that person, please. Don't be. Software development is an art form. Let's treat it as such. Review code judiciously. If you notice a maneuver that's going to cost us in the future, state it. It's okay to request changes on a pull request. I've noticed that sometimes the personality of developers plays a huge role in how they review code. I don't want to offend someone, so I'll just make this a suggestion. And they're like, I hope you're okay. And they're like, nitpick. How many of you do the nitpick thing? Even when it's not a nitpick. Nitpick. And then they write this long thing of how maybe you should check here or do this. And they're like, I'm just saying. No, you're not just saying. It's okay to request changes on a pull request. Press the red button. Press it. Request changes. It's okay. Why? Because moving fast doesn't have to equal shitty code. Be that person that advocates for standards. You can say your code is good, but it can be better. And show us how it can be better. If there are no tests, scream. Maybe don't scream, but you can just put this meme there and say, I find your lack of tests disturbing. But something I do is, and I want to encourage us all to do it, is review your own code first. How many of you review your own code? I think I spend more time reviewing my code than others. Before I move it from draft to open for review, I would have done a whole one over and over and over again. The way I would do for someone else's code, I'm like, no, you can't do this. I go back and I change it. So as I'm encouraging us to review code judiciously for others and press the red button, do it for yourself too. Make sure you are holding yourself to high standards before you hold others to high standards. Now, just in case you forgot, we've been talking about balancing the paradox of speed and quality. We've talked about how tech debt must be a business decision. We've also talked about how to avoid unintentional tech debt. Now, as much as I acknowledge that it is important to address the leadership of tech companies to place as much emphasis on quality as they place on delivery, I do think that developers have a role to play. Maybe I'll have another talk to address leadership, but today I'm addressing us. We need to learn how to communicate risks effectively. I'll ask you a question. If you were a surgeon and someone came to you and said, I want you to perform this surgery in 2 hours, but the surgery takes 10 hours, what would you say? You'd be like, nah, can't happen. Right? And you would communicate the risks, yes? You would be like, no, that can happen because A, B, C, right? If you were a tailor, I don't know if you call it tailor here. In Nigeria, we call it tailor, okay? But some maybe call it seamster or seamstress, but they all mean the same thing. So if you were a tailor and someone came to you and it's like, oh, I want you to make this dress for me. And you're like, yeah, that would take 2 weeks because I need to get the right materials. I need to draw up the designs, blah, blah, blah. And they say, no, I need it in 2 days. You tell them, do you want a situation of what you ordered versus what you got? Right? Because you don't want that person to step out tomorrow and they ask, who made this dress for you? And they point to you, right? You want to uphold your craft. But why is it that as developers, when your PM says, oh no, we have to ship this in 2 hours, you're like, yes, got it. Nah. You need to be also able to communicate risks effectively. Sometimes it's annoying and you're like, yeah, we need to ship this fast. I know that it's not ideal, but let's just see what we can do. Sometimes you have to communicate those risks. On my team, we have something we call RFCs, which is how we detail how we're going to achieve what we're going to achieve. So I make sure, I call it, okay, so when I first joined this team, I created a doc titled Transitioning from Vibes-Driven Development to Documentation-Driven Development. VDD to DocDD. Because sometimes we just do VDD, vibes. Let's just go with vibes. We'll just figure it out as we go on. But no, so we started writing RFCs. And this is one RFC from my team member. The RFC was for something she was to implement. And all our RFCs have this section, potential drawbacks and concerns. And as you can see, at the last part there, she talks about concerns related to existing tech debt management. Now, she's communicating the risks. She's saying, we have existing tests, A/B tests, by the way, that we have set up. And if we set up this new test, we're going to be extending the old one, and it's going to be more complicated. She says, because of how we handle intercom buttons in the new self-help mode, this test may block or make the attempt to move that logic to the back end harder. If the test runs for a long time, it therefore may keep complex code around for longer. She's communicating the risks of running this test, of implementing these tests. So we agreed, let's take 2 days and clean up the previous code so that we can run this test because it's important. Now, some of us in our daily stand-ups, we're trying to communicate risks, but we're not communicating risks. We're just using technical jargons. You know, the blah, 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 database did this, and then vector, and this, and that, and your PM doesn't understand anything you're saying. And then when you're done, he's like, yeah, so when would that be delivered? Can we make it by Tuesday? So before you implement anything, don't jump headfirst into implementation. Take out time to detail how you're going to get to where you're going. Take out time to talk about the trade-offs and what's going to block you from achieving what you should. Let's learn to communicate these risks effectively. Now, the last point is having metrics for quality. We have OKRs, we have KPIs. These tell us how the business is doing. What do we have to tell us how the engineering team is doing? How your code base is doing? So let's set up dashboards. You can call them code pane dashboards that help you know what parts of your code base need more love. Yeah? And then if you have that consistently before your face, you can always factor that into your deliveries. Now, disclaimer. Code craftsmanship is not about perfection. It's about taking pride in your work and continuously striving to improve the quality of the software that you build. Remember, I said tech debt can be useful when it is an intentional decision. And even when we decide to incur tech debt, it doesn't mean we should ship shitty code. If we say we're going to go with strategy A instead of B, knowing that this is a debt that we'll likely have to clean up, let's make it modular. Let's make it easily replaceable. Yes? Let's still ship clean code and code that's of high quality even when we're incurring tech debt. Just like a craftsman would constantly improve their skills in order to deliver value, as developers, we should constantly hone our craftsmanship so we can always deliver software that's scalable, reliable, and maintainable. I'm going to leave us with a question, which is, if my code were art, would it be suitable for the Louvre or stuck on the fridge close to the weekly shopping list? Still art, yes, still art, but scary art. In other words, am I proud of the software that I build? Thank you for coming to my talk.